let's look at how to solve a system that has 3 variables in it. And this is because we do not live in a flat world. We live in a 3-dimensional world, so not only is there an x and y axis that you're so familiar with, there's also a z axis. So notice that I have a system in 3 variables and there are 3 equations. So the order of doing this is choose one variable that you want to eliminate. I'm going to select y because my one coefficient's a 1. I just think it's going to be easier to create opposites. And you're going to eliminate multiple times. So you're going to, well, for sake of reference, I'm going to number this as 1, 2, and 3 to talk about them. I'm going to do elimination using equation 1 and 2. And then I'm going to do another elimination using 2 and 3. Okay? I could do 1 and 3. Both will work. So to eliminate y in 1 and 2, I'm going to need to multiply the top one by 3 and the bottom one by 2. And that produces the following 2 equations. So now I can stack and add. Just zoom in here. So that produces 16x. My y's are eliminated, plus 19z equals negative 25. So it still has 2 variables. So I'm going to do another elimination, this time with equation 2 and 3. So if I multiply this time the bottom one by negative 3 and I leave the second one alone, I will have opposite y values. So this equation 2 remains the same, and equation 3 I'm multiplying by negative 3 gives me negative 18x plus 3y minus 12z equals positive 3. And I do elimination again, so I stack and add, and when I do that I get negative 16x, the y's are eliminated, minus 7z equals negative 11. So now what I have is, if you look at these 2 equations that I've highlighted, okay, I have 2 new equations in just 2 variables. So I'm going to do elimination a 3rd time with these, and fortunately if you look at them when I stack and add, I actually already have a set of opposites. So 16x plus 19z equals negative 25. But if I didn't, I would just do elimination again, multiply by whatever I need to create those opposites. So stack and add. This time the x's are eliminated, and I get 12z equals negative 36. So if I divide both sides by 12, I get z is negative 3. So as far as my ordered triple, which is my answer here, instead of an ordered pair in the form of x, y, z, can fill in the z value. Now to get my other 2 variables, I'm just going to kind of backpedal here, and I'm going to start substituting. So I'm going to pick one of these equations, and I'm going to go with this one right here. Okay, that's already highlighted, and I'm going to substitute the value of z. So I'm going to one of my equations that only has 2 variables, not 3. So I'm going to plug in negative 3 and solve this. So I have 16x minus 57 equals negative 25. I'm going to add 57 to both sides, and I get 16x equals 32. Divide by 16, and I get x equals 2. Okay, so now I just need y. So I'm going to end up substituting one more time. I'm going to go back to one of my original equations. I'm going to go with equation number 1, which was 4 times x, which I now know is 2, plus 2 times y, and I don't know y, plus 3 times z, which I know is negative 3, equals 1. And I'm going to just solve this. So this is 8 plus 2y minus 9 equals 1. So 2y minus 1 equals 1. Add 1 to both sides gives me 2y equals 2. Divide both sides by 2, and I get y equals 1 for the solution to my ordered triple. As always, please reach out to your facilitator with any questions you have.